26 here, the local wildlife club is doing a survey where they count the number of squirrels observed in different parks. Here are the results. So we want to find the mean and median for this number of squirrels observed. And then it looks like part B, we're going to add 3 more parks, and we'll figure out new mean and medians for those. So let's go ahead and look. First thing I would want for the mean, first I'm going to find the mean. Mark it. What the heck? Let's find our mean. So to find the mean, first thing I'm going to want to do is add these, looks like 5 values together. And that will give me the sum for the mean. So 12 plus 11, 23, 33, 39, 40, 50. Oh, that's nice. Came out very nice. It's a sum of 50, I guess squirrels. So the mean will be 50, that's the sum, and divided by the 5 values we've seen, which would give us a mean of 10. So on average, it appears that the number of squirrels observed in these parks or clubs, whatever the crap this is, would be 10 squirrels. And yes, this is a word problem, so I will label it in squirrels. Squirrel, 2 R's, there we go. And that is our mean. But then it says to find the median. Okay, well, we just list these in order from leastest to greatest. At least that's the way I do it. So the leastest is 6, then 10. We got 2 11s and a 12. And the number right in the middle, I'm just going to show this process. I know with smaller amounts it may not be necessary for you, but I'm just going to show it anyways. Looks like the number right in the middle here is 11. So the median appears to be 11 squirrels. Boom. That was nice because it was a fairly small list, but it says the data contained in the table, if you calculate the new mean, and we'll find the new median as well. Let's figure out what it does, what these values do to the mean. Now it says to predict what's going to happen, and just so we understand what an average is, our average currently is 10 squirrels, they're in purple. And we're adding values that are smaller than that 10 squirrels, which means that it should lower the mean, okay? And we'll see how it affects the median as well, even though it didn't ask for it, but it's good practice. So our mean, let's find a new mean. This one. Actually, for me, all I'm going to do here is take the original sum, so I don't have to actually add those again. And that original sum was 50. And I'm going to add these 3 new values, which is 2, 5, and 5. Not commas. But now when I divide, I'm going to divide by 8, and this will give us a new mean. So when I add those values together, looks like we get 62, all divided by 8. And I'm going to go and put this in the calculator so I don't have to think about it too much. I get 7.75. So just like we thought it would, because these numbers are lower than what was the current mean, we get a lower number of values. So this is a 7.75 squirrels. And what does 0.75 squirrels look like? I don't know. But if you were anticipating looking at squirrels in the future at parks, then it looks like you'd expect to see around 7.75 based on this information. Now, another thing though, like we've been talking about, is you see how it is possible to change data and change averages. So can averages change? Yes, they can, if you're willing to look for more information. And while this one changed, I would say that's quite drastically on this one. That's why they say, well, the more people or the more of these you observe or survey, then it's likely that the numbers are more accurate, which is true. But you must be very careful because, again, it's very easy to use these types of numbers to manipulate people. Like this one, we could say, well, that's a drastic decrease in squirrels. And so are the squirrels dying everywhere? I don't know. But it should raise several questions, at least several questions, when you see data changes. If you're not willing to look into the actual results and where the results came from, then you probably shouldn't trust the information no matter what it is, okay? So, there's our mean. And by the way, averages are used quite extensively in advertising and, of course, politics, which should worry you. But advertising uses it so that they can understand how to get you to buy things without having to work so hard at it, which, again, should be quite concerning because, well, politics uses it for the same reason. Now, we had our median already. I still need the same list, though, okay? So that was 6. If I can get this to work. Stinking technology. Here, I got, we had 6, 10, 2 11s, and a 12. But these other values that we just found are smaller, right? We got 2 5s and a 2 right here. So, in order to find my median, I got to find the middle. So I would cancel out the 2 and the 12, the 5 and the 11. Just working towards the middle here. 5 and 11. And see here, we got 2 values again, which is good. We got 6 and 10 right here, right in the middle. So I got to find the median of those two. Now, you could say, because this is kind of an easy values right here, 6 and 10, what number's right smack in the middle of 6 and 10? Or, yeah, and it is 8, that's true. It's just, I'm going to use the formula for it because some of you may not have had that as quick. So we're going to add those 2 values, just divide by 2. This would be 16 divided by 2, which is 8. I ran out of space, so I'm going to put the answer below. Squirrels. Boom.